Today we'll create this simple particle animation using p5.js, but without using any animation libraries. And here is how I'm setting up my project. I'm cloning a repo of this p5 template that lets me use p5 sketch in ES module. So I'm going to clone this repo into a folder called particle-anim. So you can make your own folder anywhere you like. I'm doing it on my desktop. After that, I'm seeding into this folder and run npm I to install the dependencies. And from here on, if you're using VS Code as your code editor, you can run something like code space dot, so that VS Code will open in this very folder. But I'm using terminal-based code editor called NeoVim, so my command will be a little different than yours. In the folder and inside the source folder, we have index.js, which has a basic boilerplate code to run our p5 sketch in the instance mode. You can open up a new terminal window and run npm run dev command to start a local server, and you can visit this page to see your sketch running in a browser. And this is what I have, just a simple circle at the center of my screen. In the last video, we looked at how to create animation using easing functions in p5 sketch, and that will be also our starting point for today's sketch. And to do that, we'll need to first define a couple different variables. So I'm going to define from, which will be the from position, and to position, the target position we want to animate to, and the actual position of our circle. And let's also keep track of how much time has passed and the duration of our animation. And in the setup function, we'll initialize them. I'm gonna just use some random positions for from and to. So from will be 200 by 200, and to will be 800 by 300. And the position will be, for now, just 0, 0. And the time passed, since we're initializing it, we just set it to 0. And the duration of our animation, how about we just say 1.2 seconds? So the unit here is in seconds. And inside the draw function, we need to update our time as well as updating our position values. We only want to animate the circle as long as time passed is less than duration. So it will only animate for the duration that we defined. And time needs to advance, so time will be updated by using p5 system variable called delta time. And this unit is in milliseconds, so we'll need to multiply with 0.001, so it'll be the same unit as in our duration, which is in seconds. And it's time to update our position values. We'll use p5's lerp function so that it goes from position to, but because from and to are arrays, so we'll just do it by each dimension. So from at index of 0, which means x position, to index of 0. And by some amount, which I will call it t. By the way, I made a mistake here. It should be called lerp, not lerp. And I will store the result to position 0. So this is basically animating the x from to. And I will do the same with y. It looks exactly the same, but just use the index of 1. We haven't defined t here, so t is what is being updated. So t will be time passed divided by duration. So it'll always be between 0 and 1. And when the animation ends, meaning in this case else, if time passed is less than duration, we run this code. And if it's not, meaning the animation has ended, then we'll just set the position to position, so it'll snap to the ending position. And for ellipse, instead of drawing at center, we use our position. So when we save it and refresh the browser window, we can see that it's animating from top left corner towards the middle here. And the next thing I'm doing here is that I just copied easing equation from easings.net website. For now, I'll be using easeinoutexpo, and because it's a TypeScript code, I need to clean up some code here just like that. And then apply this function to our t value. So before we apply or use it inside the lerp here, we will just use easing function. Is in out expo, just around it. Easing function also expects a parameter x that goes from 0 to 1, so it works perfectly fine in our case as well. So now when you save and see the result, it goes slower at the start, gets faster and slower at the end. So this is our basic sketch, but we still have some work to do. We want to be able to animate not only a single, say, particle, but multiple ones. So creating variables this way will be quite difficult to manage because you end up with a bunch of variables. Like in this case, we are only animating a single particle, but we need at least 5 different variables to keep track of. So what I'm going to do next is to create a separate class to hide this animation logic. Let's make a new file in the source folder. I'm going to name it Anim. That'll be the name of my class as well. Anim.js. And I just opened it in split view so we can sort of compare and move our code to Anim class. This Anim class will also be an ES module, so we can start by saying export default class Anim. So we can use this class in other JS files. And it will have a constructor, and it will have a few methods. Say from method will define from position, and to method that will define to position. And then we will have update function that will update time, and value method that will return the value that is being animated. Now we have some basic skeleton code for our Anim class, so let's start adding some implementation. When a new Anim object is created in the constructor, we want to reset our time. So time passed will be set to 0. And with the from method, we can set the from values. We'll take a parameter called val, and this will be passed to this dot from val. And because it is an array, I don't want to just pass a reference, but I want to copy the values themselves. So I'm just gonna use a spread operator. And for now, let's also initialize our to value and the value itself. So to val, we'll be updating them later anyways, but for now, I will just set it to the same value as the from value. And same with the value itself. That's our from method. And let's move on to to method. So to method will take a to value as parameter, but we also need to know the duration of our animation. So it will take 2 parameters. The first one is the duration in seconds, and the second one will be to value. And inside the method, we set this dot duration to the duration, and this dot to val to the parameter value. And now let's move to update method. So update part will be what's inside the draw function here in our original sketch. So update if this dot time passed, which is initialized as 0 here, is less than this dot duration. This dot duration is initialized in the to method. Then I will take a t, which goes from 0 to 1. This dot time passed divided by this dot duration. We want to be able to use easing function like here, but we'll handle that a little later. And the next line, this dot val at 0, we'll use lerp, p.lerp, this dot from val 0 to this dot to val 0 using t. But here's a problem. Where is this p.lerp function come from? Because we don't have a reference to the p5 object here. One thing we can do is maybe import p5 to Anim class, or pass the p object to the constructor and then set this dot p equals p and start using p5 object within our class. But what I want to do is I want to keep my class, this Anim class, as general as possible so that it can be used with or without p5.js library. And lerp function itself is pretty easy to implement ourselves. So I'm going to just make my own lerp. So outside of the class, I'm just going to define function lerp, which takes start, end, and amount. And what it returns is super simple. Start plus end value minus start value times the amount. Oops, there is a mistake. It's called return. So this is it. That's the lerp function. So now our anim class doesn't have to rely on p5 just to use this simple function. Okay, moving on. So now it's time to lerp the y value. So let's just change the index. And I'll update our time. So here, okay, so there's another p5 variable. We were using p.delta time, but we don't have p.delta time here. So in this case, because delta time can come from anywhere, maybe from p5 library or some other canvas library you're using. So again, I want to keep this anim class as general as possible and reusable. So I'm just going to call it dt, and update function will take that dt parameter. So it'll come from wherever you're using this object and class. And the unit should be seconds. So let me just keep that times 0.001 part. So when you are passing this dt parameter to this update method, it should already be in the unit of seconds. And let's finish up the else part that sets the value directly to our two values. By the way, we are not drawing an ellipse or any other shape because our anim class will only be concerned with animating values and not drawing shapes. And this is by design. So if you're using p5 or any other libraries, you can still be able to use anim class because it only deals with animating and transforming the values that are being animated. And our value method will be very simple. Just return this.val. Now we have a simple anim class. So let's test it out. Make sure it's working. So I'm just going to replace all these variables with a single anim object. What should I call it? I'm animating position, so I'm just going to call it position. That'll be new anim. And when we're initializing it, we don't need all of these variables. Instead, we can say position that's set from method, and we'll set it to 100, 100. Position.to. To method takes two parameters, duration and the value. So duration will be 0.8 seconds, and to position, the values will be 700, 200. So that's our initializing part. And we can skip all of this long if statement and replace with position.update and just pass delta time. p.delta time times 0.001. And lastly, we need to get the actual values because position is an object. This position is an object, so we cannot access it by just using index. Instead, we need to use value method to get the actual numeric values. I'm just gonna add one more variable called pause and assign it position.value. And save it. And it didn't work. I made a very obvious mistake. I did not import this module, anim. So I'm just gonna have to do that. Import anim from anim. And when you save it, now it's working fine. By the way, we haven't applied easing function here yet. So how should we do that? I think it makes sense to add it to the update because that's where we are calculating this t value. So I'm gonna have this update method to take second parameter called ease. So that'll be a functional parameter. And whatever easing function we pass will be used to calculate the t value. And then when you're using it, just add the name of the function, ease in out expo here. And now our easing has been applied. But sometimes you don't want to use ease. And I think it'll be a little cumbersome to always have to pass an easing function like this. So what I'm going to do, I'm going to define a default value for our ease parameter, which takes x and just return x. So that's basically a linear easing. There is no transformation of the value. Whatever is passed in will be returned. So now if we remove the second parameter, when we're using update method, instead of throwing an error, it'll just be a linear easing or no easing at all. But let me put back is in out explorer because I think it looks better. So now we have a pretty good structure of controlling our animation. So I think maybe it's time to add a couple different objects, anim objects. Now let's update our main sketch. Instead of just creating single anim object called position, I can use an array called positions and also create one more variable called num particles. Number of particles we want to use. Let's just start with 10. I mean, we can always update this later. And when we are initializing it, instead of initializing a single anim object, we'll use for loop. I until num particles variable position will be new anim. And then after that, we set position from and to. So position.from will always be from the center of our sketch, but the to value will be randomized for each particle. The duration will be the same. Let's just say 0.6. But what about the value itself? How should we randomize it? Because we want to start from the center and moves in sort of a circular way, right? With some sort of radius instead of just randomly displacing each particle. I thought maybe instead of defining the absolute value, something like 100 or 200, in this case, I think it'll be more useful to use relative value. So I can say just p.random minus 100 to 100, and same with y, p.random minus 100 to 100. Instead of actually going to minus 100, which is outside of our screen space, it'll be relative to width over 2. So from the center, it could go minus 100 to the x or plus 100 to the x. So it covers the area around it relative to our from position. And sometimes we want the absolute position, but in this case, I think relative positioning will be more useful. But then how do we differentiate that? So I decided to add one more parameter to our to method called relative. So when we set it to true, this value will be relative to from, and when it's false or not defined at all, it'll just be the absolute values. So we'll need to update our class, the to method. So it'll take one more parameter called relative, and the default value will be false. But when it's true, we need to handle the assignment of two values. So I will say if relative is true, then our to value will be this dot from val at 0 plus val 0. So whatever we pass as value will be relative instead of directly assigning it to. Same with y, from val 1 plus val 1. And when it's not relative, then we use implementation we had before, just like that. So that's the initializing part. And then what about updating and getting the values and drawing? So we'll also have to use for loop to handle multiple particles. Just like when we were initializing it, we're gonna get a reference to our anim object. So it'll be positions at I index. Then we'll update that position object. So the code will be pretty much the same. And then we get the position values, the numeric array, and then we draw it. So the code is pretty much the same. Let's keep it small. And then I'm just going to delete all these sections because we don't need it anymore. Same with this part. And same with position object. And save it. And I got an error. It says, cannot read properties of undefined reading update. So it couldn't use update method of our anim object. So I made a mistake. And in fact, when we were initializing it, I set the position, I created the anim object called position, but I forgot to add them to my positions array. So I need to push that newly created position object to the positions array. That's what I missed. And now it's working. You see these tiny particles? Let me change colors a bit so you can see better. just like that. So there are 10 particles animating. And we're using relative value. Let me show you the difference. If I don't use relative here instead of true, if I set it to false and see what happens. Yes, it's all going to random position between -100 and 100 in terms of absolute coordinate over here. But because we set the relative to true and also implemented in our to method here, it'll be relative to our from position. Let's increase the number of particles to 100 and maybe make them move more distance. How about -300 to 300? Just like this. One thing I'm noticing is that when particles are sort of exploded, do you see how it's taking rectangular form? It'll be even more obvious if I increase the number of particles. Let me change that to 500. So that's 500 particles, and we randomize each position, but then the ending result looks like it's a rectangular form. I think it'll look better and more natural if it's more like circular shape. And this happens because we are using Cartesian coordinate system. When we are randomizing our position, we are doing each axis separately, right? We randomize X and then we randomize Y. But if you use the polar coordinate system, then we can define the center, sort of center of a circle, and the radius. So it'll be randomized in circular form. So that's what I'm going to do next. So before we set the position 2, I'm going to define radius that the particle can move from the center. p.random -300 to 300. I will also randomize direction it can move to. It'll be a randomized direction each time. But instead of using degrees, I'm using the radians from 0 to 2 pi radians. So it'll be p.random p.2 pi. And now when we're setting the actual coordinates of the 2 position, we'll be using the polar coordinates using sine and cosine. So I can say math.sine. I mean, you can use p.sine as well, but I tend to use math.sine because that's faster. And in this case, cosine, math.cosine of direction times radius. And the y value will be math.sine of direction times radius. And now when you save and run the sketch, you can see it's now moving in circular form. I think that looks more natural. What else can we do? How about we decrease the size or diameter of the particles over time? So the particles can get smaller and sort of die at the end of our animation. Let's do that. So just like we created positions array and stored all the positions, the anim objects within the array, we can create another array called diameters. And let's also reduce the particles to just 100. And when we're initializing, we follow the same steps. I mean, we've done it once already, so the second time will be easy. So we create diameter anim object, new anim, and we set from and to values. From, diameter is a single number, it's not an array. The diameter from, say, 40 pixels to, using the same duration of 0.6 seconds, and goes to 0, 40 to 0 pixels. And then diameters array and push diameter object we created. And when we're updating, we get a reference to diameter object from diameters array. And then we update the same way, diameter using the same timing, delta time times 0.001. And same easing function, you don't have to. I mean, you can try some different easing function. I think that'll look pretty interesting. But for now, I'll just keep using the same easing function. And we get the value, the actual value of diameter. Let me just call it diam. So diameter dot value. And for ellipse drawing, we use diam. Oops, there's a spelling error. Diameter. Okay, and save, and you get an error. Uncut type error. Val is not iterable. Okay, it's not iterable. Let's go to our anim class. Here's a problem. We assume that the value that we pass to from and to and we animate will be an array, and that's why I use here spread operator, which only works with an array data type. But for diameter we're using, the val here is just a simple number. So we need to differentiate when we pass an array value or just a simple numeric value. And here's how I'm going to do. I'm just going to add a conditional array.isArray. If the value parameter that we are passing to the from method, if this is an array, then yes, we'll just copy the values to the from value field. If not, the from value will be set to just the value because it's just a simple number. And we do the same to to value and our value itself as well. So array.isArray val, then we keep using array, otherwise just use simple value. Same here, array.isArray val. And I'll update the rest of the code in the to method. So I just updated the to method to check whether the value we're passing to the method is an array or not, and handle it accordingly. Same with else part as well. And let me move on to do the same updates within the update method as well. So I finished updating my update method, just like here. I added if statement to handle differently. If this val is an array, I lerp each x and y. If not, if it's simple number, I just use lerp once for a single value. Same with else. At the end of the animation, if this val is an array, then I snap the value to the to value for each dimension. Otherwise, it'll just be snapped to the single number to val. And now when we refresh our browser window, yes, the animation works fine and there's no error in our console. But the animation timing seems a little off. I think the easing function should be changed. I think it should start fast and get slow at the end. So I'm here on the easing standard website again. And what are some of the easing equations that starts fast and gets slow at the end? That'll be easing out equation here, easing out. And we'll just have to choose one that we like. And for this one, I'll just use ease out quint. So I'm just gonna copy the easing function, come back to our code, paste it, update. So delete this TypeScript portion of the code. And when we are updating our anim objects for both position and diameter, instead of using is in out expo, this time I will use is out quint. And that looks better. I still feel like the animation is way too fast. So let me update the duration here, 0.6, and here 0.6 as well. Because we are doing this multiple times, how about we just create another variable called duration and set it to say 1.4 seconds and update this to duration. And now, to me, this looks a lot more pleasant to look at. What else is left to do? We can do mouse interaction, so the particle animation will start where we click the mouse. So that's one thing. And the second thing is using some other colors instead of just white. So let's start with the mouse interaction first. After the p.draw function, I will use mouse pressed function. And when we press our mouse, for each anim object we have, in this case, both position and diameter. And what are we trying to do? How do we restart the animation? If we go back to anim.js, when we first create a new anim object with constructor, we set the time pass to 0. So when the time pass is 0, the animation will start again. But I don't want to recreate new anim object using constructor. Instead, what I can do is I define a new method called reset time. And when we call this method, this.time path will be set back to 0. So that's what I want to do when I press my mouse. So for each anim object, position.reset time and diameter.reset time. Is that enough? We also need to update from and to again. So the from will be set to the current mouse X and mouse Y, and the to value will be relative to that mouse position. So I'm just going to first copy position from and to from the setup function, and then come back to mouse pressed. After we reset time, paste it, but we still need to update a bit more because now from position won't be at the center of screen anymore, but it'll be the p.mousex and p.mousey. And the radius direction is all randomized, so it looks fine to me. And you don't need to push this object again because we are reusing the existing object. And you don't also need to update diameter again because diameter will just play from 40 pixel to 0 pixel again. So that's great. So now when we test it, the animation plays where we press our mouse. And because we are using relative positioning, everything works just fine. So that was easy. And the last thing we want to do here is to use a different color palette. If you search online, there are many color palette libraries out there. And I hope you can try at least some of them just to get used to it and see how they design in a different way. But the one that I want to use today is called Thing Color Palettes. I will leave the link to the library in the description. Let's come back to our terminal, open up a new terminal window in the same folder we've been working on. Then I will run npm I at thi.ng /color palette. Make sure you run this command within the same sketch folder. It is installed, and now let's come back to our code. At the top of the main sketch file, I will import as RGB function from thing/color palettes. And within the sketch function, where we define all the variables, I'll create a constant called theme that use RGB and pass in an ID number. So I can say 0, it'll return the first theme, or 1 or 2. But if you want to just pick randomly, then this library provides a constant called num_themes. So we can randomize between 0 and number of themes. So it'll look like this, math that. How about we just do it as another variable just to make it easy to read. Theme ID is math.floor and p.random num themes. So however many themes that are within this library, it'll pick it randomly and turn that into integer. So we can use that as an index ID inside as RGB function. So that'll be theme ID. And I have an error. Num theme is not defined because we also need to import it. And after that, let me just console log and see what's in it. So if I console log that theme that we picked, there are 6 different colors. Looks like they are in object format. And each object has an offset, stride, some extra data. But what we're interested in here is that buff. Has 4 channels, RGB and alpha. But the problem for us is that all the values are normalized, meaning it goes from 0 to 1. But in P5, the colors go from 0 to 255. So you have 2 choices. You can set the P5 color mode so the range is between 0 and 1, or you can multiply 255 to each channel and turn these objects into 0 to 255 range. Let me just use color mode because that'll be, I think, easier. So after create canvas, we set p.color mode. It'll be p.rgb, but instead of going from 0 to 255, we'll set all 4 channels RGBA to go from 0 to 1. And now we need to store these colors into an array. I mean, we may or may not want to animate the colors, but we will still need to store them in an array so that each particle can get its own unique color. And when we are initializing it, I say color will be picked randomly from our theme array, which has 6 colors. So I can say math.floor, p.random. Instead of just saying 6, I can say theme.length. And then we will push that color to colors array. And because our color mode has changed, p.background of 10 will be too big. So let me just keep it at 0, black. And then assign the new color to our ellipse. So const color will be colors at I index. And let's say p.noStroke, then p.fill with color. And I get an error. The color object is not a valid color representation. Let's then check color here. Just gonna console log color within initializing for loop inside setup. Yes, it's a color object. We need to access buff. So it'll be color.buff. So let me delete console logging and back to where we assign the color. Change the color.buff. And now it's working. Refresh the page and now it's a different theme colors, 6 colors in total. Refresh again and we get a different theme again. So that will be the end of our exercise here, but I already see some improvements we can make. First thing is, how about we randomize theme each mouse press instead of each page refresh? I won't do it today, but I will leave it up to you to try it out. So this particle burst will be in different color palettes. And another thing is that in the Anim class, do you see how when we are animating values, we are assuming that the array will only have 2 values by using index of 0 and the index of 1. We are assuming that the array will only have 2 elements inside. Same thing when we update. You see how when we are lerping, interpolating it, we do it twice for x and y. But the data you want to animate may have more than 2 elements. For example, if you were to animate colors, it could be RGB, so 3 elements, or it could be RGBA and 4 elements. Or if you are animating a 3D object, you need X, Y, and Z dimensions, so at least you need 3 elements. So how do we update our code? Instead of manually accessing each index value, we can use for loop here. So for loop I equals 0 until the length of the array. Or use map function or something like that. And you can make it more general than just handling number or 2 element array, but it can handle arrays of any length. Again, I will leave that up to you to try it out, and I'll see you in the next video.